Everyone, welcome to the Openreach virtual fibre to the premise tour event briefing. We've had huge interest in this event. Over 400 people have registered, and it's going to be a really exciting day. There's obviously massive interest in the full fibre journey, and we're really pleased that we've got our partners Openreach here to do a virtual tour, which is absolutely fantastic for all of the lockdowns we're currently in. So they have something called OpenStreet that they're going to take you through. I would just like to say that full fibre is absolutely key to BT's future. It's in the press on a daily basis. It was in the press at the weekend, and BT Wholesale is absolutely committed to supporting the channel. Just in terms of a few key stats, we've covered something like 4.3 million premises at the moment, which is absolutely awesome. And we committed to invest 12 billion to cover another 20 million homes, which is just fantastic. The truck is rolling, so to speak, and we're doing 40,000 premises per week, which is just an immense number to actually go through. Obviously, FTTP isn't new. Wholesale would like to say we're one of the first to actually develop this service, and we've been offering it for quite a while now. We really want to work with the channel, and we want to keep customers connected. And I think we all know how super important FTTP is to our future. FTTP obviously does broadband, but we also offer FTTP for Ethernet and other services. So this really is something that we should all be considering for our customers, and we should all be considering for the future. FTTP is only obviously part of the wholesale portfolio. And actually, when we look at 2025, when we look at the shutdown of the copper network and the move to IP, we've got a range of services in wholesale, such as hosted services for voice lines, Sajir. We've got some really exciting mobile services to do mobile data for connectivity, and we've got some really good professional services. They actually wrap around and complement FTTP. So please do get in touch with your account manager, and they'll be able to help you with it. Now, we're going to do a virtual tour, and I'm going to hand over to Dominic in a second that's going to do that. But we're also going to have a Q&A at the end, where you can ask any questions of the product teams within BT Wholesale or the product teams within Openreach. So please think about what you want to ask. There's also going to be a chat. If you'd like to put them in the chat, please just drop them as we go along, and we'll get to them at the end. So this is going to be really exciting. It's going to be super safe. It's the only tool you're going to be able to do, and you're going to be absolutely safe that you're not going to catch anything. So please sit back and enjoy it. Dominic, please, over to you. If you could just kick off for the tour, please. Thank you.
Thank you. Okay, so my name's Dominic Bottomley. I'm the Regional Learning Manager here in Bradford. Welcome to our site. Normally with these tours, we would have you actually on site itself. So obviously bear with us. Obviously this being a virtual event, a little bit different, but I think you'll like what we've got in store for you. These tours are generally highly interactive. Obviously we've already referenced about the questions, so please put those in the chat so we can get your questions and answer them for you. But before you see the video, I just want to let you know, we wanted to have a bit of a real feel to the video. So each take you see has been a one take and done. We didn't go back and correct anything. So occasionally I may misspeak, but I would have done that naturally to you anyway. And yeah, there was no real script. It's just my knowledge of the network and what I know from all the tours I've done in the past. So we really hope you enjoy it. I hope you enjoy it as much as I enjoyed making it. We're going to start the journey in the telephone exchange itself, and we'll go through the ODF, or the optical distribution frame. We'll talk a little bit about that. Then we'll look at how it transfers into the network externally. So that goes through something called a cable chamber joint. Once it gets into the network itself, it goes to something called an aggregation node. And then from there, we're getting to the really fun part where we're going to get to our splitter, which is effectively our fibre to the premise network. From there, we'll also go how we deliver that to our customers, and we will see the actual ONT, or the optical network termination unit itself, in the customers, and I'll explain a little bit about that. So with no further ado, I'd like you to watch the video, and I'll be here after for some questions, so hope you enjoy the show. Today I'm going to talk to you about fibre to the premise, and we're starting in the actual telephone exchange itself. So we're in quite a unique position here at Bradford. We've got the ODFs, okay, these are the optical distribution frames. These were the first put into any of the train sites within Bradford. I actually asked Clive selling myself. I'm really proud that I got them in. So at the ODF, this is our next generation box for housing all our fibre optic equipment. So all our GFast, all our fibre to the cab, all our fibre to the prem, which is the thing we're really interested in at the moment, that is all running through one of these boxes. The box itself, as you can see, reasonably small. It's very different to what we've had in the past. The past boxes that we've used are very reliant on a lot of splicing, where we actually connect two fibres together. That's what we call a splice. With those, a lot of manual intervention and obviously quite a lot of storage needed for the capacity we were building. With these boxes now, we've gone to what's really classed as a plug and play type connection. So after our initial splice, make our initial connection, we can then move that product around anywhere in the box and anywhere in adjacent boxes as well. So we've got much more flexibility in the way we now build our network. And also, once it's built, the speed that we can then deploy that network and incrementally build further on to as more customers come on stream is also rapidly decreased, enabling customers to come on stream a lot quicker. So let's have a look at our ODF a little bit closer. So I'll talk briefly about the spine connection, then I'll show you the actual tray itself. The spine connection is a little bit like the trunk of a tree. So it's leaving the telephone exchange and it's travelling out upon your main roads and highways out towards your customers. What the spine does is that's going to take the high capacity fibre to the prem traffic out further towards the customer. So as we build all these spines out in a telephone exchange, they're the things we concentrate on getting it out there as fast as we can, which then enables us to make those connections quicker. Okay, let's have a look at our spine connections. So as you can see, hopefully in this tray at the moment, we have a fibre optic cable coming in, and as we look really closely here, we'll see there's actually no splice connections in this tray here. This is because we're using a pre-connectorized cable. So the cable itself comes on a little drum of cable, anywhere up to about 350 meters of cable. The beauty of this is the tray and the cable are pre-manufactured for us, and we just purchase it as that. That enables us to install the tray and to deploy the cable much more quickly. We are now saving, with this boxing, the way it's being built at the moment, we are saving 144 connections having to be made. So again, that's all the man hours that it takes to make those 144 connections. As we look closer in this box, we can see that we've actually got 4 different technologies running through this. We've got our DSLAM, which is our digital subscriber line access multiplexer, and that is specifically working for our fibre to the cabinets. So that is all the super fast broadband that we all know and love. We've also got our GFast running through this, which is very similar to our super fast broadband, but it's now moving into our ultra fast technology, speeds up to 330 megabits. And we've also got our fibre to the premise running through. Again, speeds up to 330 megabits. The other technology we've actually got running through here is also our Ethernet. Again, in this exchange alone, we've got 3 different Ethernet circuits, all running up to 1 gig. The beauty with these connections, as I've already mentioned, is it's a plug and play connection. So it enables us to move the connection around where we want very quickly, as I'm going to demonstrate right now. So the connector itself is an LC connector, which for me, I'd class that as a little connector. As we're installing these, what we will do, we'll clean the end of the connector to make sure it's perfectly clean and we've got no dust particles which can interrupt the transmission of that fibre optic signal going through it. We'll also clean the aperture that it's going to plug into as well, which the other side of it is also an LC connector. We're in a test environment at the moment, and because I'm just showing you it, okay, I'm not going to clean it at the moment, but obviously if we're installing these in the real world and not under mock or test conditions, we would obviously be cleaning this. So we just put it into the slot, and then all we've got to do, push it up slowly, and we hear a very faint little click, and that shows that it's plugged in exactly as it should do, and that light's transmitting through now. The next thing we've got to make sure we do is just to run the cable into the correct channel to make sure there's the correct bend radius being used and we're not compromising any of that precious data that your customers are sending down that fibre cable. Once we've finished in that tray, we can then slide it back away and we're done. Okay, so now we've made our spine connection, let's look at how we're going to connect to our OLT, or our optical line termination. So the OLT itself is held somewhere else in the exchange, and that's got all the major connections which are bringing the broadband or the data to us so we can pass it on into the network to your customers. In our exchange here, we have a slightly different setup because we're a trading environment and because of the nature of how we've had to bring the cables in, a little bit different to a standard exchange. So ours actually come into a different section of our box, but I'm going to show you that now. In this area, we've actually got our connection coming from the outside world, coming from the OLT. We've already pre-made our connections here, and what this is doing, this is connecting our network to our spine cable. So this is what an engineer would do when they're coming out and they're building these boxes. They will make this connection from the OLT to the spine cable. But just before they do that, we've actually got to install another really clever piece of kit. I'm not going to bore you too much with the details, but this is called a WDM, which for us stands for a wave division multiplexer. Very clever name for effectively what is a filter, effectively. That's how I like to think of it. I like to think of this as just a filter. What it's doing is it's mixing and unmixing signals from our fibre to the prem circuits. So we have a connection for our OLT, where our broadband effectively is coming from. We have a connection to go to our spine network to take it to our customers. And we also have a connection for an upgrade circuit. So this is future-proofing our network so that in the future, if we or any of our providers want to send a different signal down to the customer, you've got a facility ready-made in this box, so we don't have to take customers out of service. We don't have to give downtime like we used to do for businesses when we do upgrades. All we can do is make that connection, and then the customers who are getting that service will get that service straight through. So again, by putting this inside, it rapidly increases the speed at which we can upgrade our network in the future. This clever box, again, in the past, they used to be about half this size. I wish I could show you one, but I'm really sorry I couldn't find that today. But they are roughly half this size, the old ones, and it was a lot of manual intervention. We had to do, again, a couple of splices to put it in place, so it takes quite a bit of time. This one itself has already all been pre-spliced for me. It's what we call a passive unit. There's no moving parts. All that happens is light goes in and light comes out. So this now actually has 8 of those devices inside it. To install it is really, really simple. Quite kind of child's play. I know I can do it. I find the correct shelf, which in this instance is our first WDM shelf. I take out the plastic connection and I place this inside. As I do this, I make sure I locate it in the 3 tabs. That is now in place. And that's installed. That's our network future-proofed. All the engineers have to do when they're making these connections is wiring that WDM device, wire it out to the spine, which is going out to the customers. Job's a good one. The box as it is at the moment, as we've got it wired up, will take roughly 7,000 end customers in this iteration. We can change that around. We can build this as we need it, but I would say the maximum we will get out of one of these boxes is just over 10,000 end customers. So if we compare that to a standard copper network, for example, you can see with the copper network that would take up a much greater footprint in a telephone exchange and need an awful lot more powering with batteries and a lot more processing power elsewhere. This box, just this box alone, and an optical line termination, and we're good to go. Okay, so now our cables left the optical distribution frame, our ODF, and remember I talked about that structured cabling? So that structured cabling has now brought us to this connection box called our cable chamber joint. We're still in the main part of our exchange, but normally these will be underground the exchange just before the cable goes out into the network. Looking at the actual box itself, we've got different colour cables going into it and coming out of it. So we've got a yellow cable going into it. That is our exchange cable. It's got limited fire hazard properties, so we can use that inside our exchanges. And we've got our black cable. This would normally be within a couple of meters of going out into the network, and that is our underground cable taking our data to our customers. If you're really observant, you'll also see that we've got a white cable coming out of it. The white cable actually is a black cable inside with a white over protection. That's actually a different cable we're using to deploy into our fibre network now, called a ribbonized fibre cable. That cable's actually got 432 customers, all in a very small little cable, and we'll show one of those in our network when we get to it. Okay, so we're now at our aggregation node. This is one of our major boxes on our spine network. So remember I talked about the spine being a bit like the trunk of a tree? So the aggregation nodes are little points along that. From here, these are going to lead to our large branches going out towards our customers. So the aggregation node, the best way I can really describe it is a little bit like the green boxes you see on the streets. So they're for our copper network, and they house all our cables. They all come inside, make a connection and go back off. That's exactly what the aggregation node does, but in a fibre optic sense. As we've seen before, because of the fibre technology, we can reduce the footprint of that. So now, rather than having to be out in the street, this box is now just in an underground box. So I'm going to take the lid off. The aggregation node itself, certainly the one we have here, can house roughly about 13,000 different customers. And that's a mix of technologies. So as I've already explained, coming out of our optical line termination, our OLT, which you saw earlier, what you've got there, you're going to have your fibre to the cabinet, you can have your fibre to the premise, and you have the technology of like GFast. So with this one, we've got those same technologies coming through it again, but we've also this time got different ways of sending that to the customer. We've also got Ethernet in there, and with that, we are sending to our customers on something called a blown fibre. So the fibre to the premise network we build at the moment is what we class as a structured fibre network or a connectorised fibre network. But in the past, we have tried to use blown fibre as well. So with our blown fibre, actually what we're installing is a cable such as this, and it's full of little small tubes. Look a little bit like the kind of straws you used to get in McDonald's. With these tubes, what we're doing is we make a connection on the end of it, and we send compressed air down it, and we send a blown fibre bundle. So that can be anything from 4, 8 or 12 fibres, and it's carried along on the air from where we're sending it to where we're going to. As long as we've got the correct air pressure, that is, we can send it for a very long distance, okay? So a really good way of getting out to our customers, and we still do a lot of that for our Ethernet circuits at the moment. So we've got that running through here, and I've mentioned already our Ethernet. Obviously I showed you it in the exchange, and we've got it in some of our customers around Openreach itself. Well, what we've also got coming out of here is we've got our cable called a COF 600. Okay, so this is a structured fibre cable. It has 36 fibres inside it. A lot of people, certainly it's a bit different when we're doing a virtual tour, but a lot of people, when we've done the tours when people are here on site, ask how we actually tell which fiber's which. I'll show you later on, but all our fibres are actually colour coded. So we all know in the fibre world that our primary fibre starts with blue, and then it goes orange. So you can always find fibre number 1 because it's blue, and fibre number 2 is always orange. Once we get into a cable like this though, where they're all in a sleeve, in a coating, actually what we need to do is identify which is the first pair within the actual cable itself. So again, we've got indication markers on the cable and on the dummy members inside, and we've got a red, a green, a yellow, and then 3 whites. And if you were here, I'd ask you, where do you think you'd start? And 9 times or 99 times out of 100, people normally say, well, you start at green, good to go, basically. It's not that way. We always start on red, which is a bit of a historic thing back to the 19th century with the cables we used to use then on the old exchanges. So we start at the red, and the one next to that is our first identifier. That's our first cable or our first bunch of 12. So that's where we'll start from. When the cables come into the aggregation node, effectively the light comes from the exchange, and when we're putting it in here, not to give away too many of our trade secrets, but we always find it easier to bring our cables in on the left-hand side. The reason for that is, well, I don't really know what the reason is, but the reason I've kind of made myself believe is that left for left, left for light, so the light is always on the left, and therefore conversely the customer is always right. So that always works for us in training anyway. Inside this box itself, we've got our cable coming from the exchange, and it's spliced or connected through to our cable going towards our next clever box, which is called a splitter. We'll come to that in a moment. But because I've already told you about a couple of different cables, I'm just going to show you another one that might come out of here as well. This one we've got here, if you can just about see, we've got a yellow band down the outside of it. This is an external fibre cable, but what this does, this will also go overhead. So this is a multi-element overhead fibre cable. It's got 3 elements inside again, which gives us 36 fibres, and it's got strength members down the outside of the cable, so this obviously can go overhead. This can come straight out of this box for when we need to be sending it overhead, because it's a much more rural network. And then lastly, I want to come to our brand new fibre cable. We've probably been deploying this in the network for the last year and a half, maybe 2 years, certainly when it was on a trial period. This is 432 fibres in this cable. It's roughly the thickness of a whiteboard marker, something like that, so not very large at all. Again, this cable itself has got identifiers on it, so we can see which is our first pair, which is our 432nd pair. When we come to put this in, yeah, I mentioned about this being, I think, a ribbonized cable, so we'll get a close-up of this at some point, but when we open it out, you can see that the fibres are actually latticed together or connected together. I always refer to it a little bit like a string vest, but that might be because I watched a lot of TV in the 1980s. The cable itself, when we put it into the node or into the aggregation node, because it's all latticed together, we can lay 36 fibres in one. We can lay 12 fibres in one go, and when we put it in a tray, each tray will house 36 fibres. So as we get a close-up on one of the trays, what you can see is we've got elements inside here, and they're in a much larger splice protector than we would normally use. So when we're making our connectorized connection in here, the ones that we used to use were a single fibre. So that meant we had to find the single fibre every time, which in this case here, I've got an orange. So this was our fibre 2. And this was connecting fibre 2 to fibre 2. We would have to strip the fibre cable itself. We'd have to cleave or make a really good cut against the actual glass itself. And then we'd have to place it into a splice protector and put it into our splicer machine, fuse it together, and then put the protection over it, shrink that down, and then place it into our tray. As you can imagine, if you had to do that 12 times, it's quite time consuming. We have got very clever splicer machines now, which can do a lot of the job for you. It certainly does a lot of the stripping of the fibre cable, the cleaving and the shrinking down all in the same unit. So we're definitely moving with the times. But with moving back to the ribbonized fibre cable, because all 12 are connected together, we've actually had to use a different splicer machine. So the stripping of the fibres, we have to strip all 12 at the same time. We have to clean all 12 at the same time. We have to cut all 12 at the same time, and obviously we'd have to splice all 12 at the same time. The beauty of that is, as much as it might take a little bit more preparation, and certainly preparing the cable takes a little bit longer, once we've done that, to actually splice the cables, much quicker, which means, again, we can deploy it into our network a lot quicker, and we can build our spine. Once that spine's built, then we can start branching out towards our customers, up to our splitter, and then get to where all the fun starts. Okay, so now we're at our splitter. Our splitter is a little bit like a wrong seal product, if you will. It does exactly what it says on the tin. The splitter effectively splits the light coming from the exchange going towards our customer. So if you think of it like we've got one fibre cable all the way through from the exchange, a bit like, remember the tree, and we've got the big tree trunk going through our spine. Now we're getting to a large branch coming towards our splitter. At this splitter, we're going to start to branch off into the very small little branches which will have all our leaves on, which I always like to think of our customers or our lovely flowers. So in our splitter, the light comes in and it goes through a stage of 5 different optical splits, which is going to break the light into 32 different customers. So we're going to open our lid on our splitter. If I have a look at this, handily we've labelled it as our T-split for our splitter node. If I look on the back of it, I can also see that this was installed by a fantastic engineer from the Big Yorks area. I seem to remember him here. At one point, he might be in front of the camera. Who knows? So let's open the lid up a little bit more. As we come all the way down to the bottom of our splitter, we can see in at the bottom we have got our splitters. Okay, so we've got a blue one and an orange one, and if you can remember back to our fibre colours, our blue is always our primary colour. So that's our first splitter, and that's the one that will get connected up first. They're our first lot of customers, and our orange is our secondary splitter. Now what's vitally important at this point is that as much as the light coming from the exchange can work to a customer, at the exchange the blue splitter is connected to a different port in the actual telephone exchange. So all the light coming from that port is already addressed to effectively 32 distinct customers. If we connected that up to a customer who should really be on the orange one, on the secondary splitter, as much as they would have light, there would be an awful lot of changing that would have to go in the background because they won't have their specific light. So yeah, we've got to make sure we get the right light to the right customer. So it's still quite technical. In the splitter itself, as I said, the light comes in, goes through the little splitter box, breaks into our 32 different customers, and then we send it into one of our trays. And if I open one of the trays, the first tray I get to, okay, where we're making all these connections, I can already see it's full of blue cables. So therefore I know instinctively it's on our primary splitter. So everything's good to go from this point of view. In here, again, single fibre cables now, so it needs an individual splice each time. Not like the ribbon eyes you've already seen. This has got to be done manually, single each time. The cable from here is now going to go to something called our CBT, which stands for our Connectorised Block Terminal. I'm going to show you those in a moment, but they're, again, really clever piece of technology. They will be either underground, as I've got in one of these boxes, which you'll see. They can be mounted on our poles, so that's an overhead one, or it can be even mounted on a wall outside some shops or some flats. So a weatherproof box, really good, and again, because I've referenced this as being our connectorised network, effectively it's plug and play technology. Once we've made our connection here, that makes the box live. We can just plug in with a cable and we're good to go. If I look at a few more of these connections in here, I can see I've got some more blue cables, so I know that's on my primary splitter. And if I keep going up, eventually I can see my secondary splitter. And if I look at this tray in particular, you will notice we've got some orange and some blue cables mixed together in the same one. So I can already see that this is a potential fault. We've got our primary and our secondary splitters mixed going to one of our connectorised block terminals. We don't allow this in our network. This is in here purely for us to demonstrate that this will cause an issue at the customer and to reinforce the point that it's got to be, even though all light's good light, it's got to be the right light going to the right customer. Okay, so we're now at our CBT, our Connectorised Block Terminal. As I said, it's a weatherproof box. This comes effectively in 3 flavours. So we do it in a 4-port, an 8-port or a 12-port. Obviously a 4-port for a much more rural location and a 12-port for when we're getting into very urban locations where we need a lot of deployment. I mentioned this being a connectorised network. The beauty of this cable is it's a connectorised end. So because we've already made our connection in the splitter, all this box is now live. So all I need to do is take off the end cap of this cable, find where I've got a small little arrow embossed on top of it, find where I've got a notch on the port itself and align those two. So I'm going to do that now. I've already pre-cleaned this cable to make sure there's no dust on the end of it, because again, we don't want any of that dust or debris blocking any of the light going to our important customers. I line that up. As I insert it, all I'm now doing is twisting the barrel, which has got the thread on the actual connector itself. The connector is called an OptiTap connector. As I say, the barrel, as that thread, as it winds up, it connects up against another fibre inside. That makes a good connection. Tighten it up fully, that makes it weatherproof. I've already done this already, but the end caps also have to be twisted together. The reason for that is A, it stops them all flopping around, but B, it's going to stop any dirt or debris getting into those caps. Because if we ever have to put it over the cable, we don't want to reintroduce that dirt either into the box itself or onto the end of that fibre cable. If I look at our CBT here, those of you who have ever worked in a network before, you'll know that when we have our copper network, we always start counting from the top left hand side all the way down to the bottom right. This box is the converse, so we start at the bottom left going all the way up to the top right, but the numbers are indicated on the actual connections themselves, so once you know that, it's really easy to use. If you've ever looked at any other technology, or if you're ever a fan of the comedy programme Have I Got News For You, the panel show with Ian Hislop and Paul Merton, you will have seen this box before. And you will probably have seen my shoes as well, because they had their very brief 2 seconds of fame on that show one time when we had the Chancellor of the Exchequer, Philip Hammond, here plugging in this cable itself. So there you go, little known fact. Okay, so now here at our overhead deployment of our CBT, our Connectorised Block Terminals. You've already seen it underground. We're going to look at the overhead ones. So on the pole next to me, at the top of the pole, we've got a triple-sided bracket. If you can remember back that the CBTs themselves come in either a 4, 8 or 12 port connections. So on this pole, on this bracket, we can have up to 36 customers. So we're already getting very busy now with this. Because we've only got a certain amount of room, we can put our furniture on our actual poles. It's what we call the pole top envelope. We're actually going through a process of re-stepping and moving one of the steps down a little bit to just give us a little bit more space. But whilst we're doing that, which you can imagine we've got an awful lot of poles all over the country, that will take an amount of time, the triple-sided bracket really helps us put this furniture up there and helps save a bit more space so we can use it for other things. With the CBT at the top, so now it's at the top of the pole, our light's there, that's ready for our lead to cache engineers to go out and connect it up to your customers. So to do that, they're going to use an overhead wire. With this scenario, obviously in the underground box, it will be an underground wire, probably a new estate, something like that. But with this one, it's an overhead connection going to the customer, where we'll then introduce something called a customer service point, where they're going to make the connection onto the cable into the house itself. Okay, so we're now at our customer service point. We're right outside our customer's premise. We've talked about our underground deployment, we've talked about our overhead deployment coming from our pole, and this is now that example. So just above me, I've got a fixing point on the fascia of the house. The cable's coming down the outside, and it comes into this, the Openreach customer service point. As we open this up, we can see inside we've got our fibre cable very neatly wrapped away, and we've got our splice ear protection just down the left hand side. This also has got space for any copper as well, so if the customer still wanted a copper line for any reason, this can also be housed in here, so no need to have 2 boxes. This is our last point of call before we have to go into the premise, so if the customer is not in for any reason, there should be no reason why we can't get up to this point to make that final connection a little bit easier. Coming out of here, we have what we call an inside out cable, which is going into the premise there. Obviously inside, you can see from the outside, it's a black cable. When we get inside the premise, you'll see it's magically turned into a white cable. Let's have a look in the house. Okay, so now we're in the premise. We can see we've got our very small little ONT, which is our optical network termination. Effectively like your telephone socket, but obviously this is just going to be connected up to a router, and then the customer will have a dial tone coming from that, no doubt. If you're really observant, you'll notice on this box we've actually got 4 different LEDs, one of which is the power, which is green at the moment. We've got a PON light, which is PON for us stands for passive optical network. That just basically means it's going through a splitter. So yeah, it's how we create fibre to the premise. We've got our LOS, which is loss of service or loss of signal. That's a red light. Never a good thing to have at a customer, which is what we've got at the moment, but I'll come back to that if I can in a minute. And then we've got a port light. The port light, again, it's a bit like a proof that the customer's got a connection. At the moment, we've just got our cable plugged in, no router. We haven't installed our router yet on this. The reason we haven't installed our router is we've actually got a fault on this line at the moment. Again, probably not the best thing to show when you're showing CPs how the network works, but the beauty of having a training centre is we can use our lines for all different kinds of purpose. So at the moment, we're going through a stage of having an optical test head installed at our site. Because of that, we're trying putting some faults on at the moment. So just early today, we've put a certain fault on this to see if it'll drop into loss of service, which it has. Later on, we'll be able to put this back on and make it all working again. But there you go. This is our ONT. Also outside, I mentioned about the black cable becoming a white one inside. If we see down here, we've got our small little cap, which is just covering our hole that the engineers had to drill out to the outside world. And we've got our white cable coming through. The reason we've got a white cable inside and a black cable outside is effectively the white cable has a black outer sheathing. That just gives it more protection out in the network, but also much neater for when we get inside the premise. It's a nice small little white cable with a factory made connector on the end, which is what we call an APC connector. APC, probably explain this a little bit later on when we go into the Q&A, but APC is an angled physical connection. It allows more light to pass through, but if anyone's got a specific question on, I can go into a bit more detail later on.
Good morning, everybody. My name's Alison Wilkes. I'm from the BT Wholesale Broadband Product Team. I'd like to say a big thanks to Dominic for that demo, and thanks to all of you for joining. When I thought about holding this session back at the last ISP forum, I never imagined that the audience would be this big, but it's been really good to see so much interest. So we've got the remainder of the time now for some Q&A. And I'm joined by some colleagues, Andy Hurley also from BT Wholesale, and by Bertrand Mazière and Matt Sledge from Openreach. We've got a mixture of questions that were submitted before the event, and there have been some submitted in the chat during the demo. If we don't get time to cover all of them, we will make sure that we provide answers, and we'll probably also post a full list of the Q&As after the event. First question we've got is for Dominic, and this is, we'd like to understand the terminology better. For instance, what is the SA and where is it? Okay,
thank you for that. Yeah, so we call it a SASA, and that stands for a splitter array sub-assembly. That's kind of a historic term now for me. We used to have the splitter housing a specific tray, the little metal box that has all the clever clever things inside. That was in a little plastic tray, and the legs that came out of the splitter, the 32 customer legs, they then went into 4 separate trays. Nowadays, the splitters we put in, we just actually place it in a little housing, as you saw in the video. So it doesn't actually go in a tray in the same way, but it's kind of a historic thing. We still refer to it as a SASA. So that's all it is.
That's great. Thank you very much. And the next question, I think, is to Bertrand. What are the FND team responsible for, and what are the SD team responsible for?
Yeah, thank you for that, and good morning. So quite simply, these are the 2 big operational teams. FND, they build the infrastructure for FTTP. They're also responsible for the Ethernet and optical products. And then separately, you've got the SD team, and they're more about provisioning and repairing, in particular, all the volume products, such as your broadband products, FTTC, FTTP.
Great, thanks a lot. We've got a question for Matt to take, I think. We have two concepts in FTTP as of now. One is GPON and the other one is EPON. The question is, which is the best and cost effective, or are they both good but at different conditions?
Hi, Alison, and hi to everybody. Yeah, so EPON, Ethernet PON, and Gigabit PON, so GPON, are both different standards and protocols, and they have their sort of advantages and disadvantages. The standard that we've always used in the Openreach FTTP network is GPON, and we don't have any plans at this point to roll out any EPON. So GPON is our answer.
Thanks very much. Bertrand, we've got another one for you, which is the other side of the road has new fibre. When will you do my side?
Interesting question, this one, because obviously Openreach is committed to roll out as much full fibre as possible. I mean, we've talked about an ambition to 20 million premises by the mid-2020s. When we roll out, we try to do as much of an exchange as possible. And in particular, afterwards, you know about the stop sell. We decide to stop sell the copper when we have that critical mass in the exchange. Now, we can't tell in advance whether one side of the street or another will have the service or not. But the point is, we are aiming for as much as we can, and then there can be very local conditions that may raise some exceptions, and that might explain why for a while there wouldn't be the full fiber infrastructure on both sides of the street. But the more classic case is that you would get the infrastructure on both sides. That's more common than not.
That's great. Thank you very much. Next question, I think, is probably to Dominic, which is, how is the install location of the ONT determined?
Okay, so thank you. So that is agreed with the customer. Realistically, the ONT wants to be within about 1 meter of a power source, because obviously it's electronics, so it's going to need a power source for that. And that would also typically, I think, be within about 10 meters of where the cables come in. But then realistically, again, I'm saying realistically a lot, apologies for that, but the end user or the customer is going to want to think about how they want to use that service. So you may just want to use a Wi-Fi, so you want the best signal in the room where you're going to use it the most. So that's really about the position of the router. So in those instances, if the router needs to be located into a different position, obviously we can maybe extend the data to that position, and that's where the router can get plugged in. So it's about having that conversation with the customer and understanding about exactly what their needs are and how we can best provide that.
Thanks. I think probably another one here for you is, how do you clean the connectors?
Okay, so the fibre itself, I don't have one with me. I wish I prepared for that question, but I don't have one actually with me at the moment. But we use a little kit called a stickler kit, and effectively it looks a little bit like if you think of the old, like I don't know, like a Tipex cartridge or one of those that you used to like click and it add a little bit on when you use the Tipex tape. It's a little bit like that, and it's got a tape inside. And all we do is we add a little bit of cleaning solution to the tape, and then we align the fibre to the tape. It makes it like a ka-chunk or a click sound as we depress it, and the tape, you can see my hands clearly, it kind of wipes the surface of the fibre. As it's wiping, it also rotates, so it gives a vertical and a horizontal cleaning of the actual fibre surface, which clears all the dirt and debris that might have accumulated on there. Because I don't know if everyone knows, but the end of the fibre itself is, well, I would say it's really small, but effectively it's 9 micrometers or micrometers across, which a speck of dust is in the region of about 3 micrometers across. So one little small speck of dust can have a huge effect on the transmission of that fibre signal. So it's really important we clean it, which is why we use these very clever little kits.
Okay, thank you very much. We've got some questions about FTTP and Ethernet. So I think maybe to Bertrand, is there a way to provide separation for FTTP and Ethernet into a site? Is that possible?
Yeah, I mean, so on FTTP and Ethernet, I mean, they're reasonably different infrastructure, and of course they provide different services, right? Therefore, in a way, I would argue that these are reasonably independent infrastructure. Although we also talk about single fiber networks, so that means the closer you are to the exchange, the more you share the fiber cables, if you will. But I think it also points to the question of resilience, which is on an Ethernet network, you can implement resilient services. And that's what really these lease lines are all about. Whereas we've made the choice, and I think that's quite a classic choice in the industry, that there is no resilience on FTTP because it's a broadband service. So hopefully that covers that one, to an extent.
Thank you. Andy, if I can bring you in, if we stay with Ethernet, do you want to say anything about options for customers to access full fibre for Ethernet?
Yes, good morning. Just very briefly, product availability follows Openreach availability. So as long as Openreach have installed network, we can provide FTTP over Ethernet, either by an existing cable link or simply by us ordering customers a new cable link. There's no charge. It's around about 33 working days, although I have seen improvements on that. So really the best place to find that information out is the wholesale Ethernet pricing tool. So as long as you've got your address, your postcode, NAD key, whatever, put that in and you'll see whether or not we've got Ethernet via FTTP at the moment, or whether we need to just provide a cable link to enable that for you.
Thank you. Couple more for you, John. For every customer, will they be connected to a blue fibre only, or can they be connected to the secondary orange fibre?
Sorry, who was that for?
That was for you.
Right, okay, sorry. Okay. So you're referring to the video itself. So the blue output from the splitter, that's our primary splitter. So that will that node I was showing before was a medium node. So that will be customers 1 to 32 off that node, and the orange splitter, that would have customers 33 through to 64, if my maths is correct. So yeah, it will depend how it's the network is planned, what connectorized block terminals being allocated to which splitter. So in effect, it doesn't really matter as long as it's planned correctly. I think, as I said in the video, so that the correct OLT, the optical line termination, so that the correct position there is allocated still to the correct customer at their premise, then it's all fine, it's all good. If we had a larger node where we can have up to 4 splitters in, again, historically there, what we've used is we've used 2 lots of blue and orange, and we lay them on different sides of the actual node itself. In different trays, so therefore we can identify which is 1, which is 2, which is 3, which is 4. And if it's a very small node, so much more rural location, we'd only put 1 splitter in anyway, so that would only be blue. So it really depends. The very long and boring answer is it doesn't really matter as long as it's allocated to the correct one all the way through. It'll just work.
Great, thank you. And another follow-up one for you, which is a very interesting question, I think. With the aggregation node in an underground box, will it be susceptible to impact by flooding?
No, so the aggregation node itself it's got a rubber seal around the bottom of it. So when the lid goes on the aggregation node, we make sure that one of the quality checks engineers have to do is to make sure that rubber seal has got no dirt or debris which will impact it working as it needs to do. So that's one of the quality checks they have to do before they close the box down. Also, you didn't see in the video, but because it was easy to have it off before we started filming, but the aggregation node itself has an orange clamp which goes around where the seal is, and that clamps it down tight. So therefore, again, there's no water that can ingress inside it.
Thank you. Question for Matt. There was a label with X-, 'G" , 'G" . When are you looking to provide 10 gig PON? 10 gig PON? 10 gig PON. 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 10 gig P
Well, at present, we're only building GPON, but we have recently trialed XGS PON, which is 10 gig symmetric PON, and we are considering whether at a future date we could roll out that type of technology. XGS PON isn't the only kind of next technology, so we are considering alternatives as well. But this is really more a conversation for the longer term. At the present time, we have, as I say, recently trialed, and we have some working trial services on XGS PON. But we have no firm plans to build any XGS PON or XG PON at this time.
And a follow-up question: what's the max number of connections you're providing in one PON port, and what's the max bandwidth you can give to one customer?
So at present, we and historically we've always built the GPON network with a 32-way split. So that's potential for 32 different PON connections. Now, in addition to that, we have also a multi-port ONT device, so you can have multiple connections per split, if you like. Most customers have a single port device and only use one service, but there is potential, therefore, to have multiple services on that 32-way split. So technically, more than 32 customers can get a connection on the PON.
Great, thank you. A question for Bertrand about rollout. If an altnet, for example, City Fibre, have enabled a street, does that mean that Openreach will deprioritize their rollout in that location?
Yeah, thank you. So as I've mentioned, I mean, we are building at pace, at scale, aiming for that 20 million prems, and we announce our plans quite a bit in advance, as a number of you will be aware. We share those transparency reports. As I've also said as well, we build as much of an exchange once the exchange is announced. What I'm saying with this is we have a number of ways to decide which exchanges. So we score the exchanges based on the number of classic parameters. You're going to be looking at your costs. You're looking at the potential of that exchange. But once it's done, right? So we need to go ahead and proceed, right? So that's essentially, I think my answer is the plan of Openreach is the plan of Openreach, and that's really what we're dealing with when we look at whether or not we are building.
Okay, thank you. Couple of questions for Dominic. How do you identify if the cable going inside the premise, if the box has more than one customer in the same house, more than one line?
Sorry, I don't think I fully understand the question. Do I just repeat that, please? So
if there's more than one FTTP service in the same premise, I assume it's Finch, how do you identify which one it is?
Right, okay, so that might be something like an MDU, maybe something like that, multiple dwelling units?
Potentially, yeah.
Okay, so the way this signal works down through a splitter, actually, as the light travels down, the light itself is optically split. So in effect, and forgive me if you didn't know this already, but everybody gets everybody else's data and light at the same time. The way it actually works is the ONT, the actual box itself, has a MAC address. So therefore, it's a bit like all the information traveling through the internet. That address has every little bit of information has to have an address label on it. So it's the same with the ONTs. When it gets to the ONT, it explains that, obviously, I'm the correct bit of data. I've got all this correct information. Allow me through to the router, to your customer. And if bits of data go there which is not addressed correctly, because it's for somebody else, the ONT effectively says, you're not meant to be coming in, you haven't got the right credentials, and it discards it at source. So that's my understanding of it anyway. That's how it was explained to me a long time ago. So that's how we know. It doesn't really matter, because obviously the ONT picks up the right signal from the OLT effectively.
Okay, thank you. Yeah, I think there's a lot of discussion going on at the moment about multiple services into the same premise in terms of ordering second and third circuit. So we did have a few questions in about how to order that second circuit and the use of the new multi-port ONT. So I mean, if I pick that one up, basically, yes, you can order a second circuit. I mean, if there's already a multi-port ONT in the premise with a spare port, you can activate that spare port. Or you do have the option to order a new ONT. One of the questions that we got in was whether it was possible to order 2 circuits at once, whether you needed to order the first one first. So the answer to that is yes, you would need to order the first one first and then second. Having an open order against a line can lead to subsequent orders being rejected. There are some changes afoot in terms of deployment of a new multi-port ONT, and that will mean that the single port ONTs that are currently out there at the moment, if a second line is required, that will be swapped out to a new multi-port ONT. That's not being switched on till later on in the summer, but people should look out some information coming up on that. Another question for you, Dominic. What did you have to do to induce the fibre fault? Is a fault always visible on the socket?
Right. Okay. So yeah. So what you're referring to the ONT in the video? Yeah. Okay. So what we were doing, we were introducing a bend into the fibre to see at what stage we could get the signal to drop. Again, as the light travels through the fibre, what we're trying to do is minimise the amount of bends in the fibre. The best bending of fibre effectively is a straight line, so it's just following the curvature of the earth, which is the shallowest bend we can I guess add into the fibre. So we specifically were bending the fibre tightly so that rather than the light travelling through the fibre and staying inside and coming to the ONT, it was starting to fracture and break out the side of the fibre. So we did that on purpose so we could identify we were getting that fault on the ONT, and we could just take that bend back out and fix it that way. So yeah, we did fix it. Thank you.
Okay, and just probably the last one for you, Dominic. What happens if the customer wants the ONT moved and the connectorized cables aren't long enough? Do you replace everything?
Okay, so I would think probably the easiest solution would be to get a new cable. So that might need an engineering appointment where we could just configure a new cable. I would say that would be the easiest solution.
Okay, thank you. Bertrand, we've got a sort of general question here about the difference between FTTP and FTTP on demand.
Yeah, sure. So quite simply, FTTP, we decide or we do a commercial rollout typically, or in some cases it's government subsidized funding, but we go out, we build it and they will come, if you will, on FTTP. FTTP on demand, the customer says, I need in this particular location FTTP infrastructure. So we go out and essentially take payment for building the infrastructure on demand per the name, quite simply. It's much more, by the way, I would add, it's a much more niche product, obviously. The main rollout is FTTP. FTTP on demand is really to answer a specific need in specific conditions.
Okay, thank you. Probably got time for a couple more questions. There's another one here for you, Bertrand. What part of the FTTP delivery is carried out by Openreach employees, and how much of the work is passed to subcontractors?
Okay, so when it comes to the build, it's really a mix of Openreach employees and subcontractors or contractors. When it comes to connecting the customers, so we described the SD teams earlier. Traditionally, they've been the ones connecting the customers. It is not to say, however, that they wouldn't be supplemented by additional contractors, especially when the volumes of connections grows, right? So it can be a mix, really.
Okay, thank you. And probably just got time for one more. Matt, there's a question here about higher speeds, which I know everybody's interested in right now. So if you have a 32:1 split supporting 3350, when you go to 900, I guess we're saying when you go to higher speed 1 gig services, do you still have a 32 split, or is it reduced?
Yes, that's right, Alison. So at the moment, across the UK, we have a 32-way split build policy. We've only ever built to a 32-way split policy, and that's not, we don't have any plans to change that at the present time. We do have products in our portfolio that go up to 1 gig in the downstream direction. But the majority of customers are on sort of lower bandwidths than that, and therefore we can support that on a 32-way split.
That's great, thank you. So I think basically I'd just like to thank everybody for attending today. Say particular thanks to Dominic for giving up his time, and to everybody else who's supported us with the event. We will be sending out the recording, and if there are any questions that weren't covered, we'll make sure that, that those answers are provided. And I hope you all have a good rest of your day. Thank you.